Hello everyone. Our major project is MOTAG, Moving Target Defense Against Internet Denial of Service Attacks. Next, so this project is done by Vanam Navin Kumar, Vishnuvardhan Reddy, Srivardhan Mohan Reddy, a project guided by A. Raju sir. Next, so before going to the presentation, I want to summarize this project in a short way. So in this project, author is describing a concept to save application server from DDoS attack, where malicious users can inject a place insider attack, and then this insider attack identify IP addresses and port number of application server, and then send to malicious users. And by using that IP and port number, malicious users send continuous or huge size requests to application server, and application server will busy in processing those huge requests and raise DDoS error for a genuine client. So to avoid this problem, author is using four different types of entities which will not allow you insider attacks from identifying correct or working IP address and port number of application server or proxies. Now coming to the abstract presentation. In the presentation, so distributed denial of service DDoS attack still pose a significant threat to critical infrastructure and internet service alike. So in this paper, we propose MOTAG, a moving target defense mechanism that secures service access for authenticated clients against flooding DDoS attacks. MOTAG employs a group of dynamic packet indirection proxies relay data traffic between legitimate clients and the protected servers. So our design can effectively inhibit external attackers attempts to directly bombard the network infrastructure. As a result, attackers will have to collude with malicious insiders in locating secret proxies and then initializing attacks. So, however, this MOTAG can isolate insider attacks from innocent clients by continuously moving secret proxies to new network locations while shuffling client to proxy assignment. So we develop a greedy shuffling algorithm. We use a greedy shuffling algorithm to minimize the number of proxy reallocations while maximizing attack isolation. So simulations are used to investigate MOTAG effectiveness and protecting services of different scales against intensified DDoS attacks. So this is abstract. The next page, coming to the next page, here introduction. Our networks has reported a significant increase in the have so here introduction. Our network has reported a significant increase in the prevalence of large-scale distributed denial of service attack in recent years. So in 2010, the largest reported bandwidth achieved by a flood-based DDoS attack reached 100 Gbps. So meanwhile, the cost of performing a DDoS attack turned out to be surprisingly low. A number of mechanisms have been proposed in the past to prevent or mitigate DDoS attacks. So filtering-based approach use unambiguously deployed filters to block unwanted traffic sent to the protected node. So in this paper, we propose MOTAG, a dynamic DDoS defense mechanism that adopts moving target defense strategy to protect centralized online services. So in particular, MOTAG offers DDoS resilience for authorized and authenticated clients of security sensitive services such as online banking, efficiency. So MOTAG employs a layer of secret moving proxies to mediate all communications between clients and the protected application servers. Next, coming to the system existing system. Next, here system analysis. So now coming to the existing system, here distributed denial of service attacks still pose a significant threat to critical infrastructure and internet services alike. So disadvantage is less security. So we propose this system in this paper. We propose a MOTAG, a moving target defense mechanism that secures service access for authenticated clients against flooding DDoS attacks. So MOTAG employs a group of dynamic packet indirection proxies to relay data traffic between legitimate clients and the protected servers. So our device can effectively inhibit external attackers attempts to directly bombard the network's infrastructure. As a result, attackers will have to collude with malicious insiders in locating secret processes and then initiating attacks. However, MOTAG can isolate insider attacks from innocent clients by continuously moving secret proxies to new network locations while shuffling client to proxy assignment. So we develop a greedy shuffling algorithm. Next page, we come on to the modules. What we these are there are about 4 different types of entities. And next page, here there are 4 different. I said 4 different types of entities, and here are there. Uh, First one, authentication server, proxy server, application server, client server. Let us know about them. Next page. Authentication server. So client request will be the first taken by the authentication server, and then by random shuffling greeting algorithm, it will choose one proxy server from group of proxies and then assign that proxy for that client. So here proxy is choosing using random shuffling process. So if malicious user plays any insider attack, then the attack will not able to identify which proxy server is using application server IP and port. So it will never steal IP and port number of application server. So insider attack get confused because of random shuffling process and cannot be able to attack on proxy or application server. Now coming to the proxy server. Proxy server accept request from client and then analyze request. If size of the request data is in the processing range of application server, then only it will allow client request to reach secure application server. So if request size goes beyond application server limit, then it will figure out the years attack occurred to JAM application server. So proxy server drop request and report to client or authentication server as it's in under attack. Next page. Now we come to learn about application server. Here this entity accept request from the client and the process request and the send response back to the client. So in this application we are allowing client to upload text files to application server. Then application server will receive text files and store. So basically this application, in this application server, the client sends the text file and it stores them. The size text files goes beyond limit or client send huge size of the proxy file, then proxy will not send to the application server. All received data will be saved inside received data folder and proxies will keep on moving from one proxy to another proxy. It's called as moving target defense. So client, coming to the client last, here this is a client application which can be normal malicious user who upload request to server for processing, and malicious user attack can be detected and dropped by proxies. And now we come to the architecture.
And coming to system architecture, in figure we can see the four interconnected components: the authentication server, the proxies, the filtering, and the application server. The application server provides the online services like banking and e-finance services that we want to protect and make accessible to authenticated clients. The IP address of the application server is concealed from all clients. The proxy nodes are a group of dynamic and distributed machines that rely on communication between application application server and the filtering. The authentication server is responsible for authenticating clients and assigning regiment once to individual proxy nodes. Next one. This we can see one as client authentication, and two as signaling, and three a data connection between the authentication and client, and command and control as four. And next when you go to conclusion, next slide, conclusion.
Hereby, we are concluding by saying, as we present MOTAG, a framework that employs dynamic hidden proxies as a moving targets to mitigate network flooding that DDoS attacks. To reach the protected service, authenticated clients are assigned to individual proxy nodes that perform packet forwarding and session policing. When a DDoS attack is mounted against MOTAG proxies, the authenticated clients connected to the attacked proxies are reassigned to alternative proxies at runtime, enabling them to evade the ongoing attack and maintain access to the protected service. With MOTAG, we can effectively hide the protected critical services from external attackers. Sophisticated attackers can only use insiders to locate our proxy nodes and attack them. MOTAG employs a novel, efficient shuffling mechanism to quarantine insider side attacks. Our simultaneations show that MOTAG can protect a majority of innocent clients from DDoS attacks, assisted by hundreds of insiders within a small number of shuffles. In addition, our experimental methodology and the result can be used to guide the implementation and deployment of MOTAG based on DDoS defense system.
Screenshots are used in this project. To implement this project, we design following modules. Application server is used to we design one application server to process request. And authentication server, we design one authentication server to accept request from client and assign random proxy to client. And proxies, we design two proxy servers from which authentication server choose one random and assign to client for processing. In coming to client, we will design one client to send request to server. In above screen, we will start by application server button to start server. And now double click on run.bat file from authentication server folder to get below screen. By starting authentication server button to start authenticate server will be started. By using run.bat file from proxy1 folder to get below screen and click on button to start proxy1 server. Now double click on run.bat file from proxy2 folder to get below screen and click on button to start proxy2 server. Now double click on run.bat file from client folder to get below screen. In above client screen, click on upload file to application server button. It is used to upload file to server, but this communication will happen between authentication server, random proxy and application server. In this screen, we can know about in beside screen from client application, I am uploading gcloud.txt file and after upload, we'll get below screen. In below screen, client request assigned to proxy2 by authentication server and proxy2 will send request to application server. In below authentication server, proxy2 we can see request details. In beside screen, top of the beside screen, uploading one text file with huge size and below is the result. Now this time for second request authentication server assigned proxy1, but file size is huge and proxy1 sent output as DDoS attack detected, which can see in above screen. Select test. In beside screen, proxy1 also report DDoS attack and now in client side click on attack detection graph button to get below graph. In beside graph, x-axis represents number of requests and total to process and number to detected attacks. By using screenshots, we can run this project. And finally, this is our project. Thank you.